taking a look at wiring to make sure everything was correct in the wiring. And then lab 11 was monitoring and adjusting proportional, directional, and flow control systems.
Here's your directional and flow control valve with the LVDT for positioning sensor.
Okay, we can see over here where if we're adjusting this potentiometer, this is the command voltage, this is the school positioning voltage reading, and as you can see, if this is turned up or down, you can see that the voltage is changed, and then you can see that the motor is spinning more or less. And then at a certain point, when this goes into negative, it's actually reversing the direction of the motor spinning. You can see that that's actually slowing down. It's actually reversing. It will eventually reverse. See it slowing down?
Slowing down.
It's actually reversing to another direction. And you can see here, it's now in negative. It's going slow, and then when it goes way up in negative to like going into 9 and 10, well, it's going to go to maximum speed.
Okay. Now we have the pump is on. We have the amplifier powered up. So, rather than the potentiometer, well, we didn't go for the potentiometer, but since we adjusted everything, it'll show that, okay, if you put that on the motor, I have the motor in the background here. Okay, so basically I just turned that on. You can see how it's ramping. Okay, now I'll disconnect the control voltage and go back to the motor. And then the motor, you'll see that it'll decelerate slowly. Okay, now I'm going to turn the motor on again. Here we go, so it's ramping up slower, it's not turning on at a drastic rate. Now it's disconnected again. And the motor shuts off at a good, reasonable rate. Good.
Alright, in this lab, which is 10 and 11, in lab 10, what we did was we inserted all the proper wiring inside the trainer box. And for lab 11, what we're working with is a proportional, directional, and flow control valve, which is over here. And the valve has a LVDT, a linear variable differential transformer, that's used as a position sensor to send feedback. So what we have is sorry, we can cut this part off. Alright, you're going to have to turn that on soon, Mark.
Want it up?
Yeah. Alright, so we're using a potentiometer to control the command input voltage. So the command input voltage is being sent to the amplifier and amplified to the proportional, directional, and control valve. As you can see, when the command voltage is positive, we get a directional flow of one way. When we decrease the voltage, we decrease the flow. And then when the command voltage goes negative, then we get the opposite direction, and that's how we get directional flow control. We made some adjustments on the amplifier card, one for deadband compensation to
Make sure you're not overlapping.
to reduce the effect of the overlap in the spool, right? So we use deadband compensation to reduce the overlap of the overlap in the spool, and then we use the gain adjustment to adjust. So when we have minimum command voltage, we get minimum output flow from the valve, and when we have maximum command voltage, we get maximum output from the valve.
Show the voltages in the motor speed.
Yeah, and as you can see, the higher the input voltage, the higher the speed. As the input voltage is decreased, the speed of the motor also decreases. This here is our feedback. This is our positioning of the spool. And as you can see, when we go from positive or from negative to positive voltage, it will change the direction of flow